Right, guys. Now we're at a point when we should look at graphs of the inverse hyperbolic functions. So again, like I said before, I'm always going to exploit a lot what we have done, what we have seen, so that we can connect the new things we're learning with the things we saw before. Are we together? The most important thing we're going to get here is the relationship we're going to use here. We're going to exploit the relationship of a graph of a function and the graph of its inverse. How did you say they relate? Can you answer me that question? How do they relate the graph of a function and that of its inverse? Can you tell me something? You don't want? What did I say? Come again? The graph of the inverse is a reflection of the graph of the function, isn't it? Okay, let's carry that. Let's hold on that one. Now, but it's reflected across what? What is the mirror line? Come again? Y is equal to x. So then our y is equal to x is our control kind of. What's happening here? Y is equal to x is our control. Right. So now let's get y is equal to x coming here. Roughly, there is y is equal to. Oh, what happened here? This is not beautiful. I normally like beautiful things. Okay. So this looks a bit more attractive. Now let's think about the graph of the function y is equal to sine hyperbolic. I suppose we have forgotten how it looked like, right? It looked more or less like this. I think I pulled it too much here. Does look better, no? Okay. And then you can just lengthen this one, and then cross it a bit there. Good. Now it looks nice. But there the origin is a bit ugly, but it's not a problem. Let's leave it like that for a while, isn't it? Everybody can imagine that it passes through nicely the origin. Now, if we were to reflect, like for example, the origin, let's do it this way, so that we cheat here, we cheat a bit. Let's do it this way. This point is the origin, is on the graph. So if it's going to be reflected across y, the image will coincide with the point. Are we together? So now, but if we look at this one, this point, if it's reflected across the line, it's going to stand somewhere there, and this distance is equal to that distance. Do you agree? We come on this point, we reflect this point there. This one is going to be thrown this side, and then this distance again must be equal to that distance there. Are we following? When you come to this point is on the graph and is on the graph of the inverse because it's on the mirror line. Now if we were to draw, and this one is also a point which is on the graph and the graph of the inverse because it's on the mirror line. Now let's try to trace the graph of the inverse function. It will now come, you see this one here, it will be symmetric there, there will be symmetry there. You agree with me? Then it will go there symmetrically. symmetrically right. Then there again symmetrical. So the new graph, this one, the red one, this graph is going to be y equals to sine hyperbolic second function of x. Then what I want you to do is, this is a rough sketch. When you go to your books, then just you see that you see something similar, and then I hope you understand how it came up to be like that from this discussion. Are we together, guys? Okay. Then, what is important about graph? The graph is important to analyze more or less the function, how it's behaving in this domain, whether it's growing, it's increasing, or it's decreasing, or whether it's got a curve somewhere, whether it's convex, whether it's concave. All those things are very important. Maybe that graph is describing a certain phenomena. You can say, okay, at this point the phenomena is increasing very fast, at this point is increasing very slow. Like for example here, this graph is increasing a bit at a faster rate, but when it gets somewhere here, it starts slowing down. That's an interpretation you give for the graph. It is important to know to interpret the graph when you see it in front of you. Is that understood? Okay. Can I say this is something well done? Or you've got some complaints? Are you fine? Okay, so you've got the two functions there. This one is our y equals to sine hyperbolic of x, and this one is the second function. It's going to be true again, exactly the same thing. If I say sine hyperbolic brackets sine hyperbolic second function of x, what do you expect here? X. Because the composition of the two functions must result in that y is equal to x. The mirror line. All together? Good. So, are there any questions? Now guys, the next graph concerning the inverse of hyperbolic function is going to be the inverse of cos x or cosine hyperbolic x. This is the graph we've got here, and here is supposed to be 1. Now again, if we're going to look at an inverse, we cannot overlook the mirror line y is equal to x. So let's put the y equals to x line here. Okay, so I don't need all of it there. Now, if we look at this now, we expect that this point here is going to be reflected across the mirror line to get a point there. What will be the number there? 1. And we expect that point 1, 0 to be on the graph of the inverse function. So this we've got 1 point. Now, if we come here, this line being a perpendicular line there, we expect a point somewhere there to be on the graph. And similarly, if we come somewhere here, we expect a point there to be on the graph. Now, if we talk about this point here, check this point. We throw it across the line like this. I think it's going to be somewhere this side. Do you see that? Do you see that? So now, we follow all those points. You find that those points are going to follow somewhere there. So precisely, the reflection of this graph across the mirror line is going to be a cup which is lying more or less on its side, and sorry, I'm just trying to shape it nicely. It's going to look more or less like that. Like that. All together. Then we can say this is the graph of the inverse. But can we say this is a function? Question. What is the problem? Sorry? The vertical line test fails. This is what this gentleman is saying. So since the vertical line fails, then it's not a function, but we are interested in getting a function out of it anyway. What should we do? We have to discard one part, especially this part. Let me just highlight that. The part from here, the repetition, actually what represents the repetition there? From there, going down, we're going to get rid of that altogether. So what I'm going to do, I'm going to pick my eraser and get rid of this. And get rid of this. Get rid of that. Then once we've got rid of that now, we can comfortably call this. We can comfortably call this a function, and the name of that function is y. What is happening? Why is this thing picking up? You see, it doesn't want to pick the pen. This will be y equals to cos hyperbolic second function. All together, guys. So up to that point, I think I've illustrated how to get the graph of the inverse functions. But now to come to tan, I think to tan hyperbolic, we didn't really discuss tan hyperbolic as a graph. Did we discuss it? No, we didn't. So now what I'm going to do, I'm going to discuss it briefly with you. Then I let you go and figure out how you can get this graph of the second function tan. This far, I think I'm going to stop this thing and say thank you. Then let's look at tan in the next section.